In this video we are going to discuss signal flow graph algebra. That means rules to simplify signal flow graph. Here we are going to discuss. So you can see rule 1. For example, if you are having a branch in between two nodes x1 and x2 like this, definitely you can write x2 is equivalent to a into x1. This value into your gain transmittance, that means gain of this branch. A into x1 will be output. Here input is x1, output is x2, and here this is a branch connecting these two nodes with gain A. So in this case we can represent x2 is equivalent to ax1. Similarly, so in this same rule 1, if you are having like this, if your output node is getting signals from multiple nodes, then how we can deal with that node. So here output is x3, x3 is equivalent to a1 x1 plus a2 x2. We can write like this, a1 x1 plus a2 x2, combination of that two lines gains is nothing but the output gain. So now coming to rule 2, if you are having branches and nodes like this, if you are having 3 nodes x1, x2, x3 and 2 branches are going to connect these 3 nodes. So if you are having like this, you can take out this x2 and you just take this signal flow graph with 2 nodes, just 2 nodes, by multiplying that gain AB and x1, x3. So you can take out this x2 node and you can write x1, x3 and the multiplied gain AB. You can reduce the signal flow graph like this. Why means, for example, if you consider this, if you consider x2, x2 is equivalent to ax1, right? According to rule 1, x2 is equivalent to ax1 and x3 is equivalent to bx2. If you consider x2 value, that is equivalent to ax1. So bax1 will be is equivalent to x3. So here if you observe here, ab into x1, abx1 will be equivalent to x3. We are getting the same. So now coming to rule number 3. If your nodes and branches are like this, then you can consider these two branches are parallel branches and you can make this as single branch like this. Between the same two nodes, you can make this as a single branch and that branch gain will be equivalent to a plus b. So here x1, x2 will be the two nodes. Generally these two nodes, here we are having two branches. So if you are having that parallel branches, then you can reduce that to single branch by taking that parallel branch gains in addition as a resultant gain. So here if you observe this, x2 equivalent to ax1 plus bx2. So here we are having x2 is equivalent to a plus b into x1. So x2 is equivalent to a plus b into x1, you are going to get the same. That means ax1 plus bx1 will be your output x2. Coming to rule number 4. So here similar to here, I am taking out this x3 node. If you are having like this, if your signal flow graph is like this, we can make this like this also. That means we can take out this x3 and we can directly multiply these gains and we can connect these nodes like this. That means, so you can connect your nodes like this. So this is x1 and x2. I am not taking x3 node, I am just taking x1 to x4, x2 to x4 connection. But whatever the gain in x3 to x4 path is there, that I am adding two sides. So that means adding means I am multiplying two sides, AC. So this is AC into BC. So here I am having x4 node. Why I am writing like this means, here you can see x3 is equivalent to ax1 plus bx2. So according to here, x3 is equivalent to ax1 plus bx2 and x4 is equivalent to Cx3. If you multiply this x3 value here, then you are going to get the same ACx1 plus BCx2. If you observe the output here, so this is equivalent to ACx1 plus BCx2. You are going to get the same. If you taken out this x3 also, you are going to get the same. That is why our rule number 4 states that if your signal flow graph is like this, you can model this like this. Coming to rule number 5, if you are having feedback loop, if you are having feedback path, so here you are having feedback path. If you are having feedback path, then you can take that feedback path like this. That means, so B by 1 minus BC you can take. So similar to block diagram reduction. So here if you are having feedback, then that feedback path you can consider like B by G by 1 plus GH or G by 1 minus GH form we are writing, right. So here you can see this is a positive feedback, because for C I am not having any negative sign. So that is a positive feedback. For positive feedback, the gain formula is G by 1 minus GH. Here G value is B, H value is C. So that is why I written B by 1 minus BC. So this is x1 and x2 and x3. If you are having like this, then definitely you can write x1 to x3, these two are multiplied, AB into 1 minus BC. Like this we can write AB into 1 minus BC will be your gain. You are going to get like this. So here we are having one formula, that is you can take out this loop and you can write this as multiplication. For example, how we are writing this means based on rule number 2. If you do not know rule number 2 also, x2 is equivalent to ax1, x3 is equivalent to, so b into 1 minus bc into x2. In place of x2, I can substitute b by 1 minus bc into ax1. So ab by 1 minus bc into x1 will be your x3. So here you can observe x3 is equivalent to AB 1 minus BC into x1. You are getting the same. So here I applied rule number 2 again. So if you are having 3 nodes like this connected like this, you can take out that middle node and you can multiply that series gains. So similar to block diagram reduction, here we are doing. If parallel is there, we are adding. If series is there, then we are multiplying the gains. So these are the simple rules in signal flow graph reduction. In the next class we will see some problems related to signal flow graph.